I am so pumped to be going over Newton's method with you. It is something that a lot of people leave out of a calculus course, but every once in a while you've got a calc professor or AB or BC calc teacher who goes over this. It's actually really cool. So we're going to spend just a video or two going over this thing. Newton's method is very simple. It was an 18th century mathematician's graphing calculator's way of zeroing a function. So when you have a graphing calculator or graphing software, we're able to figure out where a curve crosses the x-axis. We're going to use Newton's method to approximate that. And you might say, well, why do we need to know this? One, it's pretty cool seeing what tangent lines can do. And two, it actually ties into something you're going to be learning later on in calculus, known as Euler's method. And even beyond that, it actually links to something called Taylor series. Believe it or not, it's very, very neat how everything builds on itself. So you don't necessarily need to know this in an AB or BC class. It's not on the AB or BC exam. Again, some teachers and professors love doing it. So let's actually see this method in action. What it basically is a bunch of tangent line approximations that are going to approximate zeros. So let's start out with just the algorithm. So I'm just going to give you the algorithm to start, and then we're going to see where this algorithm comes from, that formula. And we'll do a few exercises, and we'll call it a really quick lesson. Complete 3 iterations, so 3 cycles of Newton's method to approximate a zero of f of x equals x squared minus 5, and use x equal 2 as your initial guess. So what's going on here? Well, what we're essentially saying is the initial value that we have is x equals 2. That's x sub n. We're going to subtract out f of 2 over f prime of 2, and that's going to give us an approximate for a zero of x squared minus 5. We're going to do this 3 times. We'll repeat it. All right, so, well, we need f of 2, first of all. So what's f of 2? Well, f of 2 is not so bad. F of 2, and you're definitely, by the way, get your calculator. Get it handy. We're going to need it. I've got mine ready to rock and roll, that's for sure. So f of 2 is equal to 2 squared, which is 4 minus 5 is negative 1. F prime of x is equal to 2x. That's not going to change. So f prime of 2, that's the f prime of x sub n, is equal to, well, 4. So this is all equal to 2 minus negative 1 all over 4. So that's equal to 2 plus 1/4. So I guess I'll do this as a decimal. That's 2.25. That's x sub n plus 1. So call this like x sub 1, your first guess. This would be x sub 2. All right, so we have now started off. We need 3 iterations. That's iteration number 1. So now I want x sub 3. What's x sub 3 going to equal? Well, it's going to equal the previous x term we just approximated, 2.25 minus f of that x value, which would be f of 2.25, all over f prime of 2.25. So essentially, you use this formula to get your first x value. Then you plug that x value that you got out into the formula again to get out your next x value, all of which are approximations of a zero of this. One of the zeros. Okay, so what does this equal? Well, f of, we'll do our work over here, f of 2.25, I'm going to use my calculator for that. I'm just plugging it into this function. 2.25 squared minus 5 is equal to 0.0625. Oh, that's fun. And then f prime of 2.25, what's that equal to? Well, we're going to do 2 times 2.25. That's not hard. That's 4.5. Okay, so our approximate now is 2.25 minus 0.0625, all over 4.5. Plug it into your calculator. Here we go, 2.25 minus 0.0625 divided by 4.5. So that is approximately, we're going to round this, 2.236. So we're getting closer to our approximate. That's x3. We do it one more time. I said 3 iterations. I don't know why I did 3 here, but here we go. It's simple. X sub 4 is equal to, well, 2.236. Now it gets plugged in everywhere. That's it. You just take the last answer you got and plug it into the function. Now, all I'm going to do is I'm going to go full-on calculator with all of this. So there's actually a way to program your calculator to do this. I'm not about showing you how to program your calculator in these videos, but you could. So we get 2.236 minus, f of 2.236. Well, that's easy. That's 2.236 squared. So I'm actually going to take the value I got in my calculator and square it and subtract 5. That's a really small number, and I'm going to divide that by 2 times, right, f prime of this number right here. So that's going to be divided by 2 times the number that we got out, 2.236 and change. Okay, that's going to be a really, really small decimal. All right, so again, I'm doing all this out, so 2.236 minus that answer that I just got out, and that's approximately, so I'm just going to call it some number. How about that? That's approximately 2.23, well, 596, and it keeps on going on and on and on and on. Anyway, that's the approximate zero. What's the true zero? Well, let's see. Set x squared minus 5 equal to 0. X squared is equal to 5. We know we get 2 zeros, but we're looking at the positive one here. X would be equal to the square root of 5. And if you do the square root of 5 in your calculator, what do you get? 2.236. Not so bad as an approximation. So we just approximated the zero, a zero of that function. So the question is, why does this work? And that's what I'm actually going to hit in the second bunch of videos, which is, why does this expression work? Let me just show you what just happened, though, on this next graph. So what happened is we had a point, and we guessed x equals 2. Why did we pick x equals 2? It's a nice number to start with, and 2 squared minus 5 gives us a value close to 0. So we use that tangent line, and essentially what's happening is we're saying, where does that cross the x-axis? And now we're saying, okay, take that point, right? So take that point right there on the curve where we cross the x-axis, and now we're going to do a tangent line from there. And that tangent line, look, it gets closer. Crosses the x-axis here. Ah, that's your new x value. Take that tangent line there and see where it crosses. Oh, until you finally get pretty darn close to the true value. So you're repeatedly basically saying this. You're saying, give me the tangent line approximation at 2, which would be y minus, well, the y value would be 2 squared is 4 minus 5, negative 1, which is equal to, the slope we know is 2x, so at x equals 2 is 4, times x, again, that was at x equals 2. So all we're doing here is taking this tangent line and saying, you know what, I want to know what y would be, so y equals 0. And we're solving for x. That's all we're doing. And so we solve for x, we get 2 equals 4x minus 8, 10 equals 4x, x equals 10/4, which is 2.25. Ah! Then we go again and we say, all right, where are we at 2.25? So now you got the point 2.25 comma some y value on the curve, and you find its tangent line and set y equal to 0 and keep going on and on. So you're taking 3 tangent line approximations where you're saying the y value on the tangent line is 0 because we want to know where we cross the x-axis. What's the x value? And we get closer and closer to the answer, assuming we picked a value pretty close. This would not be a good guess here if we pick like x equals negative 1. It's too far away. Right? So you pick a number that is relatively close to what gives you 0 for your y value. All right, it's not easy to understand conceptually, but it's very easy to apply. I'll see you in the next video where we go deeper into why the formula works the way it does. Peace.